Okay guys, the purpose of my videos I'm putting together is trying to explain really a lot of the real basic stuff. I feel like there's a lot of good content out there on the internet for Picoscope. A lot of my stuff is going to be redundant, and I realize that, but I'm just trying to get to that real basic stuff that I feel like a lot of content creators don't include very much. For the guys just starting out, and I was this same way when I was starting out, is just trying to wrap your mind around where you place your leads for what you're trying to capture, or playing around with the software. And there's a little bit of stuff out there that's pretty good on that, but I'm just trying to cover some of the basics, get you going on using your Picoscope. It's a powerful diagnostic tool, and it really helps speed up diagnostics in my mind. Gets you a solid answer without what we call a non-intrusive test, where you're not removing components like doing, say, pulling all your spark plugs to do a compression test. And you can do relative compression. I'm going to get into that. That'll be kind of part 2 of this video. For now, I'm just trying to cover some of the basics. So, also, I'm a GM guy. I work at a GM dealer, so everything I reference is going to be for GM vehicles. That's kind of that's my niche, I guess you could say. But all this stuff really applies to any vehicle. You can use any of this video content and apply to anything you're wanting to work on. So, us GM guys, it looks like a lot of other dealers as I've seen out there, different kind of manufacturers. But anyways, they have Picoscopes. GM sent us a Picoscope years ago. It was kind of I think they made it an essential tool, just send it out to everybody to have. Really for NVH stuff, your vibration analysis, trying to find vibrations and whatnot on cars. And man, if I can put some videos together on that stuff, the NVH stuff is way more powerful than what GM has us using it for. So there's so much more that goes into just that software, and that side of the Picoscope is amazing, really is. Anyway, so I think they send 2 and 3 channel scopes out. Those scopes work just as well. They'll do all the stuff every Picoscope will do. You'll have a few differences. If you got an older scope, it might have a slower sample rate or whatever, but their sample rates all work for what we do on cars. You shouldn't have an issue with it for the most part. And that being said, there's also cheaper Picoscopes out there, the 2 and 3 channels. I don't have their model numbers currently with me, but they'll kind of do a lot of the same stuff. You just got to be careful because their input voltage tolerances and all that kind of stuff. You just want to pay attention to some of those specifics, but that's for another video if I cover that. I don't know. If you guys want me to, drop some comments. I'll get into that. This one here, so I own my own scope because I like to have my own tools. I don't like to go looking for them. And the GM stuff, they just don't give you a lot of the leads and stuff. They're not essential tools, so a lot of shops don't have them. So this one here is the 4425A, which is, I think, the most common Picoscope guys are using out there. And again, it does all the same stuff as every Picoscope does, with the addition to what they call the BNC Plus leads. I'm trying to get this on camera here where you can see these contacts right here. So you get all the BNC Plus leads have contacts on them. The end of this one here, you can see these contacts if I can get it into focus. But what it does, it identifies the lead. So this one right here is an ignition pickup, which I'll be using in this second part of this video for the relative compression. But as soon as I plug this into the scope, the software identifies it and knows that that's an ignition pickup lead. Good feature for some guys starting out that don't want to have to set up the software as much. It doesn't matter either way. Once you get used to using the software, it doesn't really make much of a difference. I think one of the neatest parts of the BNC Plus is the BNC Plus amp clamps. The reason being, you got the same contacts there. It'll identify that this is an amp clamp. Not a big deal. But what it does also is there's no batteries in this clamp. I hate having 9-volt batteries or whatever in an amp clamp that you don't use for 6 months at a time. When you go to use it, you're in the middle trying to test it, and maybe your battery goes dead, or maybe it's just dead and you got to go get a battery. It's like super annoying, I find it. So through these contacts, it'll power your amp clamp. It will also zero your amp clamp. A lot of these amp clamps, if you can hook up other amp clamps that use the right connector for it, so they have a little button on them that zeroes them. So if you hook up, you might be reading some sort of amperage, and you have to, before you clamp over whatever wire you're wanting to test, you're supposed to zero it to, just one of those extra steps. This is a self-zeroing through that BNC Plus connector. Great feature. Really, not having to have the batteries is the number one for me. That's perfect. And then you've got, I've got regular voltage leads. There's all kinds of stuff. Let me grab one of these older leads. These ones right here. These are my test drive leads. They're extra long, but they're not BNC Plus. So it has the old style. They call it like a D9, or I don't know what they call it, but you'll see this on all the older scopes, especially the ones that GM has sent out to all the dealers. And the nice thing about the 4425A with the BNC Plus is it's backwards compatible. So you still have the same connector. I'll show that again. You still have the same connector, like right here. These connectors here that just, you plug it in, it doesn't self-identify, it doesn't do the zeroing, but it works all the same. So the 4425A is backwards compatible with all the other leads that you may or may not already have in your own tool set or your shop's tool set. So that's another major plus, is no matter what leads you already have, you can still use them. And then we'll go over here to the software. All right. So all I'm going to do right here is I'm going to plug in my scope to the USB, hooking it up to the computer basically. And then it's going to identify your scope. So you can select, yep, that's the one I want. So here's your typical setup of any scope, really. This is any oscilloscope, that your time, how much information you're capturing goes from left to right, and it is your time base is across the whole screen. So whether you're recording, let's see, we'll pull this one right up here. This is our time base. Whether you're recording in milliseconds or whole seconds, 5,000 seconds, that's a lot of time, whatever that comes out to. Let's say 50 seconds, that's nearly 1 minute, so it would record 1 minute of time before it would reach to the right side of your screen, basically. So that's how that works. That's your time base is always left to right, and then your voltage, your pressures, and whatever it is that you're scoping is always your vertical axis. So right now, we're, this blue channel here, we're on voltage, it's set to 20 volts, so your zero line is center, so it'll read anything below 0 volts to -20, anything above 0 volts to +20. And you can change that as well. I'll show you here in just a second. This stuff is really, once you start using it, you're like, okay, this is easy. So in your time base, you can measure milliseconds. If you're doing some super fast signals, like say CAN bus or anything faster than CAN bus, any of your communication circuits, you might even get into the microseconds. This thing will basically it'll split 1 second into 4 million partitions, basically 4 million pieces of information. So that's the fastest it can go, is going to be 5 nanoseconds on the 4425A. I've never had to scope anything in nanoseconds. That's super fast stuff. I have not needed to use yet. You likely won't run into unless you guys are using it for some really fast stuff. So the automotive application, typically you're going to be in the microseconds, And usually in microseconds, I'm 50 plus microseconds is about as fast as I've ever probably taken it or needed to go. And then you'll be up in your milliseconds. And then, so like say for the relative compression, I probably do 500 milliseconds. And what that's doing is, I'm actually looking at my deals down here. This should be 5 seconds of time. So each square here should be 500 milliseconds or half a second. So 500, half a second by 10 squares, you're coming out to 5 seconds of information going across your screen left to right. And then, like I said, when you need to really get into that fast stuff, you just change it. It's just on all the time. There's no, you see that bar progression like we had earlier, because it's just showing that whole 2 milliseconds of time. So we're 20 milliseconds of information. I mean, it's just there right now, so there's no progression like on your 500 milliseconds. It's actually progressing because we can actually see that time progress for 5 seconds of time. So that's your time base. Okay, and then we can look at our probes. So here, you know, each channel, respective channel where you're plugged into the scope, this will be channel A. It's currently on manual mode, so I can select, you know, if I'm looking at 50 millivolts all the way up to 200 volts. I'd have to look at the Picoscope site to verify this, but I think 100 volts is the max input voltage on the 4425A. Anything above that could damage your scope, so then what you use is your attenuator leads, or an attenuator. And what that does, like you've got like a 10 to 1 or a 20 to 1 attenuator. So we'll take a 10 to 1 attenuator, for example, reduces the input voltage to the scope by a factor of 10. So I can take that 100 volts. If I'm inputting 100 volts, that lead will change the input voltage to the scope of 10 volts. And the scope would either A, display 10 volts, or you can tell that it has an attenuator lead, and it'll do the math and put it back to what its normal voltage is. So it'll show 100 volts, but the scope is actually only getting 10 volts input to it. So it's just a safety measure to protect your scope. Anyway, so so here you can change, what your voltage is that you're looking at, right? So I just changed it to 50 volts. There's positive 50 volts, negative 50 volts, and we're starting right here at the 0 line. AC coupling, especially for relative compression, and some other, we'll get into that in other videos, but some other, depending on what you're scoping. What that does when you change the AC coupling is, say I was hooked up to my battery right now, and I was reading, say, 12 volts. My line would have been in here somewhere. And when an AC couple is going to drop that 12 volts to 0 volts. The reason being now is my 12 volts is now at the 0 line, and I can say I want to read plus or minus 200 millivolts. And we're still reading 12 volts here, but it's at the 0 line, so any changes, if I'm at this 200 millivolt reading, it's really zooming in at that 12 volt line to see the changes as you're using some load on the battery. That's not changing the voltage of the battery very much. You can zoom in on it and get much more detail in your pattern. So I'll go over that again in the following video on relative compression. And then of course you can do a auto detect, which is actually kind of annoying, especially when you're hooked up to something. It'll be jumping around. It's going to change your scales from millivolts to plus or minus 2 volts, 10 volts. It'll just jump all over until it sees some sort of input where it's going to say, okay, we're on the 5 volt scale, so it'll select that and stay there. It's going to auto select it for you so that you're going to have a signal on your screen. But if you know what you're scoping, I prefer manual mode. That's what I do. So that's really about it. We can get into some of the bandwidth limits, and you can invert your you know, if you hook up a positive and negative backwards, you can invert your waveform basically, because if you're backwards, it's going to be reading, you know, your 12 volts, positive 12 volts is going to be down here somewhere, right? And then you just invert it, and then it'll just put it upright like you're expecting to see. There, you know, a lot more features that we can get into. I didn't want to cover all that. We're really trying to be kind of basic on this video. Of course, you know, you got all these kind of tools down here, again, for another video. Triggers, I'll do on another video as well. When you're scoping some fast signals, like say CAN bus or a 3-phase pump, or maybe even like an ignition output or input. If it's a real fast signal, it might, your first waveform will be here and here, and then your next screen it might be here and over here. It's just going to be bouncing all over the place, real hard to see what's going on. So you put a trigger on, it'll hold your waveform still in one spot. So we'll go over that in another video as well. So this is really just the real basic stuff. We're talking about your X and Y axis, where your vertical is your voltage, your X axis is going to be your time base. And that's enough to get you started. So really, you can get in here, and if you're not seeing what you want, you can always play around with it. It's like if your waveform's real small, maybe you need to go to a smaller voltage scale, which will make it a bigger waveform and you can see it better. Same with your time base. If you're just not capturing it, or you have too much information at once, it's like, okay, let me make it a faster time base, and now all of a sudden it'll spread out your capture you're currently getting, so you'll be able to see more detail. So just play with it. I mean, once you use it a few times, I promise you it gets easier, and it's super easy to use. And really all the Picoscope is a very, very, very fast voltmeter. So depending on what you're hooking up, I mean, you can read pressure waveforms and all this kind of different stuff, but you have, say like your, trying to think, the pressure transducers, they are reading pressure and they're turning that signal into a voltage signal. Your scope is always just scoping voltage. So it just depends on, you know, what you're trying to read and what leads you're using. You're always basically reading voltage though, but we'll get into a lot of pressure transducer stuff, and I'm trying to think of the names of some of these. It's kind of escaping me, but anyways, we'll get into that in other videos, and there is a lot of the other content that covers this stuff really well as well. So this button here and your space bar will start and stop your capture. So when you're wanting to stop your capture and analyze the waveforms, again, we can get into that. Actually, I will be getting into that a little bit in the following video. So one other thing that I didn't cover, I was going to at the beginning. So this is voltage lead. It doesn't matter what you're scoping. If I do a relative compression, if I do a 5-volt circuit or a CAN bus, you got your one lead has 2 ends on it. The black one always needs a ground. Sometimes when you're measuring signals on a computer, sometimes it's nice to grab the same ground the computer's using. Sometimes you can grab the casing of your ECM, PCM, whatever it is you're scoping. That'll clean up your signal. Sometimes you're getting real dirty signal, try to grab the ground that your computer's using. But anyways, typically just any ground usually works pretty good. And then, you know, your colored lead is going to be whatever it is you're scoping. So if I'm grabbing that 5-volt circuit, or I'm grabbing a CAN bus, CAN high, CAN low, that's going to be the probe. You know, I've got alligator clamps, you've got back probe terminals. I won't get into probing, and that there's a lot of opinions on that, and you guys can find your own way of probing, whether you want a pierce probe, back probe, front probe. All depends on if you need that circuit working, or if you're just looking for signals. You know, we can get into probing sometime and look at the differences of each one, but I'm not going to tell you which one's better or worse or whatever. But anyways, when you're scoping, You need a good ground, and then hook up to that signal that you're wanting to see. And then you got 4 channels, so if you got 4 signals you need to look at, you can look at them all at the same time. That's really about it. Very basic on the Picoscope, but pick it up, start using it, and it'll change your diagnostic capabilities drastically. I can promise you that as well. And as always, guys, comment below, let me know if I went over anything too fast or missed something that you wanted to see here, understand better how it works. Let me know. And then also like, share, and subscribe if you want to. I'll try to put more content out, trying to get this Picoscope and get some of the basics and showing you all of it, and you know where to hook up your leads, how to hook up your leads, how to change your time scale, your voltage scale, using triggers, all that kind of stuff. And there is other content out there, so for a lot of that stuff. So you just let me know what you want to see, and I'll try to put it together. Thank you.